Now, uh, today's class is about the bunching process. Now, once the electron leaves the buncher cavity, they are drifting from buncher cavity to catcher cavity with a velocity given by the equation v1 equal to v0 into 1 plus beta I v1 by 2 v0 sin omega t0 plus theta g by 2. Is it okay? So listen my point here. So here what I want to say is, once the electron leave the buncher cavity, the meaning of that is now the electron is after the buncher cavity. So we know that after the buncher cavity, they are because of the velocity modulation process, the velocity of the electron is v1. That's why here I told that they drift with a velocity given by the equation v1 equal to v0 into 1 plus beta I v1 by 2 v0 sin omega t0 plus theta g by 2. So in that equation, what is small v0? It's answer to my question. Small v0 is
velocity
of the electron before the buncher cavity, or you can say like before the velocity modulation process. And capital v0 is the DC voltage, and v1 is the amplitude of the RF signal. Theta g is the transit angle, right? And d0 is the time at first grid of the buncher cavity. Now, next continuation is the electrons that pass the buncher at Vs is equal to 0. Listen carefully. The electrons that pass the buncher at Vs is equal to 0 travel through with unchanged velocity V0 and become the bunching center. Once again, I am repeating the sentence. The electrons that pass the buncher cavity at Vs is equal to 0. What is the meaning of this? The last class I told that applicate diagram. Do you remember that? So this is the applicate diagram, and this is the point B. At this point B, what happens? The amplitude equal to 0, and this is the maximum positive voltage, and this is the negative voltage. So whenever RF signal voltage is equal to 0, there is no change in the velocity of the electron. That's what I am saying here. The electrons that pass the buncher cavity during the positive half cycles of the microwave input voltage travel faster than the electrons that pass at the gap then when Vs equal to 0. Is it okay? So what I want to say is, yesterday also I told that V equal to V0, V greater than V0 and V less than V0. What's the meaning of this? So in this case, moving faster. In this case, traveling slower. In this case, with uniform velocity, that is V0. Here also same. So positive half cycle. During the positive half cycle, input voltage Vs travel faster than the electrons, and during the negative cycle, Vs travel slower than the electrons that pass up the gap when Vs is equal to 0. Is it okay? That means when you go for the, please try to recall that. Suppose this is the cavity. Like this is the cavity. So here one more cavity. Like this. So this is the drift space actually. So some electrons are moving from buncher cavity to catcher cavity. So some electrons are moving with faster velocity, some are slower velocity with respect to the uniform velocity. And whenever Vs is equal to 0 with uniform velocity and Vs is positive, faster than the Vs equal to 0, and Vs is negative nothing but slower than the Vs equal to 0. So finally what I want to say is, so all are bunched at one place. Now, so I want to represent that bunching process, and where the bunching occurs, the bunching distance from the buncher grid, I want to show with a diagram. Just observe this. Suppose this is buncher grid. Look at this diagram, you will get the clarity. This is the buncher grid. Suppose like this. So I want to take 2 cycles here. I want to take the 2 cycles here, and this is negative value, right? And this is Vs equal to 0, and this is Vs is positive. Is it okay? So Vs nothing but here RF signal. So RF signal is having the maximum positive voltage. This is the point, and the negative voltage. This is the point. 0 voltage. This is the point. So I want to assume the times here. Suppose I want to take the points A, B, C like that. A, B, C, and the time is here Ta. I want to assume like that, and here time is Tb, and here time is Tc. So I want to assume like that. That is your vehicle. You can take T1, T2, T3 also, no problem, nothing wrong in that. So here what I want to say is the electrons are formed like a bunches after traveling some distance. So I want to assume the distance as bunching distance. The distance is bunching distance, and I want to denote that is with delta L. Right now, these are traveling after traveling some distance. Some bunching is occurs. So already I told that when Vs equal to 0, that is traveling with uniform velocity. Suppose here. So here I want to assume that at the distance Td, the bunching is occurs. Suppose like this. Now Ta time. So this is the negative voltage, and traveling with slower velocity. So wait a while. I want to clearly. Just wait. Right. So this figure shows that bunching distance. So maximum negative voltage for the RF signal is Ta at the time Ta. Next Tb is the reference point here, and Tc is positive cycle. So you can say that. From Ta, actually from Tb, this is traveling with the same velocity. SAMB, I wanted same velocity. That means V0, and Tc nothing but here faster. And at the point Ta, this is slower. Is it clear? Please ask me if you have any doubts. Because this is the point at negative value, so that's why Vs input signal travel faster than the electrons that passes the gap when Vs equal to 0. That is Tc point, and Ta point is slower. And this is the same velocity. Same velocity nothing but traveling with the same velocity. That is V0 here. Okay. And here I want to take the one complete cycle. Complete cycle nothing but 2 pi. So 360 degrees. That is 2 pi. That is from this point to this point 360. Or you can also say that. So this point to this point is 360. So from this point to this point 360 nothing but, and this negative point to this point is 180. Okay, that means here I want to take the point is like this. See, from Ta to Tb, this is pi by 2 omega, and from Tb to Tc, this is also pi by 2 omega. Is it okay? So actually time period is T nothing but what is the T? T equal to 2 pi by omega. T equal to T pi by omega, and T by 2 is pi by omega. Is it okay? Actually, when you go for this is the complete cycle. So complete cycle time period is T. This is equal to 2 pi by omega. So here I want to take from this point to this point. That is only half cycle. That means you can take T by 2 equal to pi by omega. Again in the half cycle, this is half part, this is half part. That means pi by 2 omega, pi by 2 omega. Is it clear? Look at this point. Once again I am repeating. So from this point to this point is nothing but only half cycle here. Half cycle nothing but pi by omega. Again in this. So from Ta to Tb separate and Tb to Tc separate. That's why pi by 2 omega, pi by 2 omega. Is it okay? Now this figure shows that trajectory of minimum, zero and maximum electron accelerations. That means it is traveling with same velocity, square velocity, fast velocity. So minimum, zero and maximum electron accelerations. Now the distance from the buncher grid to the location of dense electron bunching for the electron at TB. I am repeating once again. The distance from the buncher grid to the location of dense electron bunching. There is electron bunching for the electron at TB. See here. So I want to assume that the bunching point is at the distance TD. So we have time TD. So this is the distance. So this is the bunching point. Now here what I want to write is the distance from the buncher grid. That means from this point, from the origin, buncher grid to the location of the dense electron bunching. Location of the dense electron bunching nothing but so TD point for the electron at TB. So first I want to write the electron at TB. So you can write the distance as okay, here I want to write. So I want to write the distance delta L equal to right here. Delta L equal to V naught into TD minus TB. This is the equation number 1. Is it clear? I am repeating once again. Now look at the equation. The distance from the bunched grid from the origin to the location of the electron bunching. So location of the electron bunching nothing but at the point TD for the electron TB. For the electron TB nothing but so V naught into TD minus TB. Similarly, you can write the distances for the electron TA and for the electron TC. Now tell me, what is the distance for the electron TA? TA? What is the distance for the electron TA? You can write so V into TD minus TA. Is it true or not?
Yes.
But here already we know that TA nothing but it is minimum. So minimum velocity. That's why I want to write V minimum. Don't confuse. So minimum velocity. That's why I want to write V minimum. So V minimum TD minus TA. And similarly, for the electron at TC, for the electron TC is V maximum. So V maximum into TD minus TC. TD minus TA, TD minus TC. Again, from the second equation, you can write that is equal to V minimum into TD minus. I want to write with the with respect to reference electron. There is nothing but TB. Now tell me, what is TA in terms of TB? Please look at the diagram. Look at the diagram and tell me what is. Look at the diagram. So tell me that TA in terms of TB. See, TA nothing but what is this upper limit minus lower limit. So this total this is TA. Total this is TA. But I want to write in terms of TB. That means you can write TA is equal to S. Any guesses? Anyone respond? What is TA in terms of TB? See, this is TA and up to this is TB and this part is pi by 2 omega. That means you can write TA equal to what happened?
Pi by 2 omega. Pi by 2
What are you doing? Simply so all the mobiles are keeping aside and enjoying. So T is equal to TB
plus pi by 2. 2
plus
omega.
minus.
Minus
See,
pi by 2.
I want to write TA in terms of
Pi
TB.
by
So
2
total this
omega.
is TB So TB minus 2 pi by omega. Is it okay?
Minus, sir. Okay,
Similarly, we
sir.
can write TC is equal to TB plus 2 pi by
2 pi by omega.
right. Now I want to substitute those two in this. So V minimum TD minus TB plus pi by 2 omega. This is equation number 2. And similarly in this V maximum equal to TD minus TB minus pi by 2 omega. This is equation number 3. Is it okay? So look at each and every equation and ask me if you have any doubts. Don't hesitate to ask the questions. So finally equations 1, 2 and 3. Now continuation. So from we know that after the velocity modulation process, the velocity of the electron v1 equal to v naught into, once again I am writing the equation. So 1 plus beta I v1 by 2 v naught sin omega t naught plus theta z by 2. Okay. When you observe the equation number 2 and equation number 3, there I am writing v minimum, v maximum. Actually, we know about the v naught and we know about the v1. So what is v minimum? What is v maximum? Here we know that v minimum nothing but, so their Vs is negative and v maximum nothing but their Vs is positive. But here I want to write the v maximum, v minimum. So coming to this equation, in this equation 1 plus beta I v1 by 2 v naught sin omega t naught plus theta z by 2. And what is the maximum value of sin theta? What is the sin theta range?
1 into pi by 2.
Sin theta range.
Sir, 2n plus 1 into pi by 2, sir.
So why there is directly you can say that in between plus 1 to minus 1, right? So maximum value is plus 1 and minimum value is minus 1. There is a range actually.
Okay.
So V maximum and V minimum. Now I want to write the minimum and maximum velocities. Minimum and maximum velocities. So minimum velocity V minimum equal to V naught into 1 minus beta I V1 by 2 V naught. This is equation number 4. And you can also write as V maximum. So V maximum equal to V naught into 1 plus beta I V1 by 2 V naught. This is equation number 5. Okay. Right, V minimum, V maximum completed. Equation number 4 and 5. Now I want to substitute equations 4 and 5 into equations 2 and 3. Substitute that. That means in place of V minimum, substitute equation number 4. In place of V maximum, equation number 5. Then you will get the distance delta L equal to V naught into 1 minus beta I V1 by 2 V naught into TD minus TB plus 2 pi by omega. And from this, so simplify this. After simplifying, you will get the answer as V naught into, directly I want to write the answer, TD minus TB. You can simplify later. So V naught into TD minus TB plus. So I am writing direct equation. Meaning of that is there is no difficulty to write this answer. If there is any difficulty, definitely I will give the conditions. There no difficulty. Simply by multiplying, you will get the answer. That's why I want to write the direct answer. V naught into TD minus TB into V naught pi by 2 omega minus V naught into beta I V1 by 2 V naught into TD minus TB. So minus V naught into BI V1 by 2 V naught into pi by 2 omega. right? So this is the equation, and similarly when you substitute V maximum, that is V naught into 1 plus beta I V1 by 2 V naught, you will get the another equation. When you substitute V maximum, and you will get the equation directly. I want to write the equation delta L equal to V naught into TD minus TB plus minus V naught into pi by 2 omega plus V naught beta I V1 by 2 V naught TD minus TB plus V naught beta I V1 by 2 V naught pi by 2 omega. So you will get these two by substituting 4 and 5 in equations 2 and 3. now what I want to say is, here different distances like TA at TA, at TB, at TC, and finally all are meet at the point TD. Now, in order to get the high power, to get the more power, whenever all the electrons are reaches one point at the same time, you will get the more power. At the same time, all the electrons has to reach the same distance. So why all the electrons reaching at the same distance? Nothing but, suppose here the bunching is occurs at the at time TD. At time TD, that means up to that distance the electron has to travel. Suppose few electrons are travel up to point D, and some electrons are travels only up to point C. What's the meaning of that? You can't get the more bunching. In order to get the more bunching, all the electrons has to travel the same distance. Now, the necessary condition for all electrons to meet at the same distance delta L is, I'm repeating once again, the necessary condition for those electrons, here I am considering only 3, for those electrons TA, TB, TC to meet at the same distance delta L is, can anyone, what is the condition? Any guesses? At the same distance, tell me one thing, when you go for the, just think once, when you go for the reference electron, that is at point TB, what is the distance delta L equal to? Respond please. Delta L equal to, for the time TB or for the reference electron, what is the distance delta L? Already I told the equation, delta L equal to
V naught into
V
TD
naught
minus
into TD
TB.
minus
V naught
TD.
into TD minus TB. Now look at these two equations. When you get V naught into TD minus TB, so whenever this second part equal to 0, is it true or not? If the second part equal to 0, then delta L equal to V naught into TD minus TB. Similarly, the second part equal to 0, again delta L equal to V naught into TD minus TB. Actual delta L equal to V naught into TD minus TB, nothing but that is the distance for the reference electron at reference point at Vs equal to 0. So here what I want to say is, the necessary condition for the electrons TA, TB, TC to meet at the same distance. The same distance nothing but you have to get the same equations for 3 electrons. Same equation nothing but V naught into TD minus TB. So in order to get the TD minus TB, here the condition is this whole thing equal to 0. Similarly, this is also equal to 0. That means whenever the question is what is the necessary condition for the electrons to meet at the same distance. So when you go for this equation, the condition is V naught pi by 2 omega minus V naught beta I V1 by 2 V naught, this whole thing equal to 0. And coming to this equation, this whole thing equal to 0. These are the two conditions. Clear about this?
Yes, sir.
Okay, right. It's continuation. Now continuation. So whenever that is equal to 0, that means your V naught into, I want to take the V naught as common, pi by 2 omega minus beta I V1 by 2 V naught into pi by 2 omega minus V naught into beta I V1 by 2 capital V naught TD minus TB equal to 0, right? This is equal to 0. That is the necessary condition. And from that equation here, I want to take the V naught is common from these two terms. Again, minus V naught into beta I V1 by 2 V naught TD minus TB equal to 0. So next step is, after this, next step is, now again I want to write next step is V naught into pi by 2 omega minus beta I V1 by 2 V naught. It's a lengthy one, but easy one. Just you have to remember the concept. It's very easy. Just try to compare the first equation, second equation, third equation like that. That is very easy. So equal to V naught Bi by 2 V naught. So please observe the difference between the small V naught and capital V naught, TD minus TB. Okay, and from this both sides V naught is gets cancelled. Now we can write finally beta I V1 by 2 V naught into pi by 2 omega or minus pi by 2 omega minus is equal to beta I V1 by 2 V naught into TD minus TB. Now I want to take the condition as if pi by 2 omega greater than beta I V1 by 2 V naught into pi by 2 omega. Is it okay? If pi by 2 omega greater than beta I V1 by 2 V naught pi by 2 omega. What is the meaning of this? When you compare these two, you can neglect this term. So by neglecting this, that means here doubt is how can you get this value is more compared to this, means definitely when you go for the design of Klystron amplifier with the proper values of beta I, V1, V naught and omega, definitely you will get this value is very less when you compare with the pi by 2 omega. With the proper design consideration only, here the condition is pi by 2 omega greater than beta I V1 by 2 V naught pi by 2 omega. So you will get the clarity when you go for the problems. So with this condition, you can write, so beta I V1 by 2 V naught into TD minus TB is equal to pi by 2 omega. And from this, TD minus TB is equal to pi V naught by omega beta I V1, right? Because 2 gets cancelled. 2 gets cancelled. TD minus TB equal to pi into V naught by omega beta I V1. But what is our main aim? Bunching distance. So bunching distance, that is delta L. So bunching distance is delta L. Now delta L equal to what is the formula actually? Small V naught into TD minus TB. From this you can write V naught into pi V naught by omega beta I V1. This is one of the most important equation. This is one of the most important equation. Delta L equal to V naught into TD minus TB, that equal to V naught small V naught pi capital V naught by omega beta I V1. So this is equation number 6. Not completed. It will take few more minutes and few more equations are there. V naught into pi capital V naught by omega beta I V1. Okay. Up to this, okay, actually. Sometimes question is bunching distance. Find the bunching distance of a two cavity Klystron amplifier. At the time your answer is like delta L equal to small V naught into capital pi capital V naught by omega beta I V1. But sometimes the question is you have to find the optimum distance. Optimum distance. Optimum distance nothing but when you maintain that much of distance, definitely you will get the high bunching. Is a point. Optimum nothing but maximum. So at that distance, there is a minimal optimum or optimal. There is a minimum distance at which the maximum bunching is occurs. In this case, that thing you have to find. Sometimes question is you have to find the optimum distance. That means what should the spacing between the buncher and catcher cavities in order to achieve a maximum degree of bunching. I am repeating once again. This is the distance. This is the distance between the buncher grid and catcher grid for the bunching process. Okay, when you maintain, for example, when you maintain like 5 microseconds or 5 milliseconds, whatever, 5 nanoseconds like that. If you get some bunching, what happens when you go for 4? What happens when you go for 3? Or what happens when you go for 6, 7, and up to so on like that? That means where? At what distance? At what distance? At what distance? It provides the maximum degree of bunching. That is nothing but optimal distance. That is nothing but optimum distance. So here question is, sometimes the question is like this: what should the spacing between the buncher and catcher cavities in order to achieve a maximum degree of bunching? If the question is like that, again you have to continue this procedure. This topic again you have to continue. Whenever the question is what should the spacing between the buncher and catcher cavities in order to achieve the maximum degree of bunching. So to achieve the maximum degree of bunching, or you can put this heading as to achieve the maximum degree of bunching. To achieve the maximum degree of bunching, you have to maintain some optimal distance. What is the formula for that optimum distance? Right. So I want to continue that for the purpose. Since the drift region is a field free, the transit time for an electron to travel a distance of L. I'm repeating once again. What is the meaning of transit time? Electron is from cathode to anode, but here I am talking about the distance between the buncher cavity and catcher cavity. So the distance traveling from buncher cavity to catcher cavity. So I want to assume the distance is L. Right. Before writing the equation, please tell me one thing. When you go for the transit time equal to tau, what is the formula? D by V naught, right? What is D here? D means here spacing between cathode and anode, and V naught is velocity of the electron, right? So whatever the velocity of the electron to travel from cathode to anode, that is V naught. But here, suppose this is the buncher cavity and this is the catcher cavity, buncher cavity, catcher cavity. Now the electron is drifting from buncher cavity to catcher cavity. I want to assume that this spacing is L. So the distance is L, and it is traveling with a velocity. Can anyone? Any guesses? What is the velocity? What is the velocity of the electron to travel from buncher cavity to catcher cavity? Yes, please tell me what is the velocity?
V1.
V1 is the velocity because this is after buncher cavity. So don't say it is V naught, right? That means what is the formula now? Suppose I want to assume that the transit time is T. The transit time is T, and the T is equal to T2 minus T1. So how can you get this T2 minus T1? How can you get this? In the last class, I posted a diagram. So look at that. Before the velocity modulation process, there I indicate that T0, T1, T2 like that. So look at the diagram, you will get the clarity. So that means buncher cavity, catcher cavity, T2 minus T1 is equal to, actual formula is D by V naught, D nothing but L here, and V naught nothing but V1. Is it okay? So T is equal to T2 minus T1, or that is equal to L by V1. And that is equal to L by V1. What is V1? So once again, you have to write 1 plus beta I V1 by 2 V naught into sine omega T naught plus theta Z by 2. That's it. So this is the transit time. That means to travel an electron, a distance of L with velocity V1, and that equal to L by V naught into 1 plus beta I V1 by 2 V naught sin omega T naught plus theta Z by 2 whole power minus 1. Is it okay? 1 by 1 plus x, you can write 1 plus x whole power minus 1. So 1 plus x whole power minus 1 nothing but 1 minus x plus x square up to so on. I want to neglect the higher order terms. By neglecting higher order terms, you can write L by V naught into 1 minus x. That means 1 minus beta I V1 by 2 V naught into sine omega T naught plus theta Z by 2. Up to this clear? So here I want to use the formula 1 minus x whole power minus 1. And I want to neglect the higher order terms. Right, now that equal to, and here T is equal to L by V1. But here L by V naught is there. So I want to write this as T naught. This is T naught. I want to write T naught. So T naught into 1 minus beta I V1 by 2 V naught sine omega T naught plus theta Z by 2. So this is equation number 7. This is equation number 7. Now I want to write this equation in terms of radians. So frequency nothing but f, angular frequency nothing but omega, right? And units of frequency is hertz, units of angular frequency is radians. Is it true or not? Frequency units of omega nothing but radians. So I want to write this equation number 7 in terms of radians. In terms of radians nothing but just we have to add omega. So omega t is equal to omega t2 minus omega t1. I want to write in terms of radians. That equal to, we can write omega t naught into 1 minus beta I v1 by 2 v naught into sine omega t naught plus theta g by 2. Here you can write in terms of radians. Then only you will get the clarity. Okay. And that equal to omega t naught minus omega t naught beta I v1 by 2 v naught sin omega t naught plus theta g by 2. Right. Now finally omega t naught minus omega t naught beta I v1 by 2 v naught sin omega t naught plus theta g by 2. That is okay. Now tell me one more thing. What is theta? Yesterday class I told that theta g. Theta g nothing but transit angle, right? So theta g is the transit angle. What is the formula for this? Yesterday I told that omega tau z. So tau is the transit time. But here I told that t is the transit time. Here, and tau is the transit time, omega tau z. Whenever t is the transit time, you can write omega tz, or you can write theta naught equal to omega t naught. So in place of omega t naught, now I want to write theta naught. Don't confuse. I want to write theta naught. So theta naught into, here also theta naught beta I v1 by 2 v naught into sine omega theta naught plus theta z by 2. Right, where theta naught is the DC transit angle, where theta naught is the DC transit angle between two cavities, right? So between two cavities, and the formula for theta naught is, already we know that omega T naught, or you can also write as omega L by V naught. Omega L by V naught, that equal to, you can write as 2 pi capital N. Theta naught equal to omega T naught equal to omega L by V naught, and that equal to 2 pi capital N, where N is the number of electron transit cycles in drift space, where capital N is number of electron transit cycles in the drift space. Right? And I want to take a parameter here. I want to take a parameter and I want to define a parameter. That parameter is x. Okay, so the equation numbers are, and this is equation number 8 and this is equation number 9. I want to define a parameter x, and that x is equal to beta I v1 by 2 v naught into theta naught. This is equation number 10. Very, very important equation. So all these are very, very useful when you go for the problems. And coming to mathematical analysis, one by one equation you will get one by one equation. But when you go for the problems, these are very, very important. I want to define a parameter, that is x is equal to beta I v1 by 2 v naught into theta naught. So this is known as a very, very important parameter. This is known as bunching parameter. Bunching parameter of a klystron. Bunching parameter of a klystron. So by substituting this equation in equation number 8, now we can write the equation as, see, in place of theta I beta 1, you get beta I v1 by 2 v. In place of this, we can write x. That means we can write the equation as theta naught minus x into theta naught minus x into sin omega t naught plus theta z by 2. X into theta naught minus x into beta I v1 by 2 v naught sin omega t naught plus theta z by 2. Now here just I want to calculate the value of x. So in order to calculate the value of x, you have to go for the Bessel's function. So here first I want to give direct answer for the optimum distance. After that I want to give the induce the currents also. So the reason is, in the last class also I told that about the two concepts, that is velocity modulation process and current modulation process. And in the buncher cavity, velocity modulation, and in the catcher cavity, I told that current modulation. That means you have to talk about the velocity of the electrons whenever the RF signal is in the buncher cavity. So whenever all the electrons are drifted from the buncher cavity to catcher cavity, then you have to go for the current. So current modulation process, right? And it is a periodic signal. Whenever it is a periodic signal, you have to go for the Fourier series representation, and from the Fourier series representation, you have to write some Fourier series coefficient like a0, an, bn, up to so on like that. And from those equations, finally you have to get the value of x, and that value of x you have to substitute into equation number 10. Then you will get the optimum distance. Okay. So first directly I want to substitute the value of x. Later I will give the equations for currents in the catcher cavity. Okay. In the examination also depends upon the question, you have to write the answer. Now after this equation, I want to write the optimum distance L at which the maximum fundamental component of the current occurs. Maximum fundamental component of current nothing but, see, up to now I am talking about the velocities and all those things. Now it is bunching is completed. Actually, once bunching is completed, that bunching is at the catcher cavity. So there you have to talk about the currents. There you have to talk about the current. That means the drift space converts the velocity modulation process into current modulation process. Now I want to write the optimum distance L. The optimum distance L, that is L optimum. L optimum. So in order to write the L optimum, so we know the formula theta naught equal to omega L by V naught. At the same time, we know that formula x is equal to beta I V1 by 2 V naught into theta naught. And from this x is equal to beta I V1 by 2 V naught into omega L by small V naught. And from this L equal to or L optimum equal to 2x beta I V1 by 2, sorry, L optimum equal to 2x V naught by omega beta I V1. L optimum equal to 2x capital V naught small V naught by omega beta I V1. Here x value equal to 3.682. Sorry, not the x value, 2x value. That is here x value equal to 1.841. This is coming from the Bessel's function. So why you have to talk about the Bessel's function? That means when you go for the currents here, that is in the form of Bessel's function. So from the Bessel's function, you have to take that x is equal to 1.841. No problem, I will give the clarity for that. But remember that x is equal to 1.841 or 2x is equal to 3.682. So with this, we can write L optimum equal to 3.682 into small v naught capital V naught divided by omega beta I V1. Right? This is the optimum distance for the bunching process, or this is the optimum bunching distance. Is it clear, all of you? Optimum bunching distance. See, two formulas here. In the previous case, I told that delta L equal to something. Now here L optimum equal to 2x small v naught capital V naught by omega beta I V1, and x is from the Bessel's function. Here no problem. Here don't need to read about all the Bessel's functions. Directly you can take x is equal to 1.841. Suppose if you want to write, like, you can write the current is having the maximum amplitude when x is equal to 1.841. Like that you have to write. The current is having the maximum amplitude when x is equal to 1.841. Therefore, you can substitute x is equal to 1.841 into that equation L optimum. So finally, you will get the equation as 3.682 small v naught capital V naught by omega beta I V1. So because of this distance, or the distance given by, okay, because of this distance, you will get the 15% more. 15% more. That means what I want to say is, when you go for the equation delta L equal to something, right? Already we have the equation delta L equal to something, and the distance given by this equation is 15% less than the optimum distance. That means we are having delta L and L optimum, two formulas. Delta L and L optimum. So delta L is 15% less than the optimum distance. Is it okay? So that is the optimal distance. So this part is okay, but I told that I want to give the current formulas also. Current formulas also for that reason. For that reason. So when you go for the current, you have to talk about the charge also, right? Suppose if you want to talk about the current, you have to talk about the charge also. It's continuation of this. Now at the buncher gap, a charge dq naught, assumption. At the buncher gap, a charge dq naught passing through the time interval dt naught is given by. At the buncher gap, a charge dq naught passing through the time interval dt naught is given by, already we know the formula, dq naught equal to I naught dt naught, right? Actually dq equal to I dt. I think we know the formula, I equal to, what is the formula? dq by dt, right? And from this dq equal to I into dt. Now I want to assume that at the time t naught, that is dt naught, the charge is dq naught. So you can write dq naught equal to I naught into dt naught, where I naught is the DC current. Again, I want to start it from the first. Now, from the principles of conservation of charge, from the charge conservation, principles of conservation of charge, the same amount of charge dq naught also passes the catcher cavity at a later time interval dt2. So what I want to say is, in general, that means entering charge equal to leaving charge. When you go for the principle of conservation of charges, you can say that leaving charge is equal to entering charge equal to leaving charge, like that. So entering current equal to leaving current. Is it okay? Similar to that, here I want to assume that, or I want to consider the conservation of charge. So from the principle of conservation of charges, the same, that means what is the meaning of that? We are neglecting the losses. So by neglecting the losses, we are neglecting the losses. The same amount of charge, passes the catcher cavity. So dq naught is the at the buncher cavity, and same amount of charges passes the catcher cavity, but definitely it will take some time to travel from buncher cavity to catcher cavity. Now I want to go for the time is time is not t naught. So initially time is t naught. Now I want to go for the another time, that is maybe t2, maybe t2, right? Now at that time I want to assume that the current is equal to I2. At the catcher cavity, the current equal to I2, and the time is dt2. But the principle of conservation of charges, the same two currents are equal. That means you can write the first current is I naught dt naught, and at the catcher cavity current is I2 dt2. Now clear? So at the buncher cavity, I naught dt naught, and that is passed towards the catcher cavity. So I want to assume that current is I2 and time is t2. So I2 dt2. But from the principle of conservation of charges, you can say that the amount of charge at the buncher grid is equal to the amount of charge at the catcher. So when you give the modulus, I naught mod dt naught equal to I2 mod dt2. This is equation number, equation number 12, right? And this is equation number 11. Okay. Now, from equation number 7, what is the equation number 7? Look at once. Equation number 7 is T2 minus T1 equal to T naught into 1 minus beta I V1 by 2V naught sin omega T naught plus theta Z by 2. This is equation number 7. And from this, T2 equal to T1 plus T naught into 1 minus beta I V1 by 2V naught sin omega T naught plus theta g by 2. Don't confuse here, you have to take some assumptions actually. And that equal to here I want to take T1 minus T naught equal to tau. T1 minus T naught equal to tau. So what is capital T actually? Capital T is separate, right? What is capital T? See, capital T equal T2 minus T1. Capital T equal to T2 minus T1. Now I want to go for the T1 and T naught. What is T2? What is T1? What is T naught? Look at the previous class diagram once. So already I told that. In that I mentioned that T naught, T1, T2, all those things I mentioned. Mention all the time intervals. So here I want to assume that T1 minus T naught equal to tau. So whenever T1 minus T naught equal to tau, is wait a while. Right. So 10 minutes, within 10 minutes I will complete this. Now T2 equal to T1 plus T naught. Again here T1 minus T naught equal to tau. That means we can write T1 equal to T naught plus tau. T1 equal to T naught plus tau plus T naught 1 minus beta I V1 by 2 V naught sine omega T naught plus theta z by 2. Now again this equation I want to write in radians. Suppose this is equation number 13. Now this also I want to write in radians. Please write that equation in radians, nothing but you can write this is T2, right? Same equation, just write in terms of radians, that is omega T2. Please write equation here. So omega T2, omega T naught plus omega T plus omega T naught, like that. You got into this whole thing. Right? So now from this I want to write omega T naught plus omega tau nothing but I want to write theta z, and omega T naught nothing but theta naught. The 1 minus beta I V1 by 2 V naught sine omega T naught plus theta z by 2. Same notations you have to use. Don't confuse. That's why you have to follow starting from the first equation. Okay. And from this that equal to, in the next step, I want to write omega T naught plus theta z. I want to write theta z by 2 plus theta z by 2, because here we are having sine omega T naught plus theta z by 2, and theta naught minus theta naught into beta I V1 by 2 V naught sine omega T naught plus theta z by 2. Right? And what about this? In place of theta naught into beta I V1 by 2 V naught, nothing but this is x. That is x. Now directly I want to write the equation because it will take so much of time. Again here no confusion, directly by solving this we will get this equation. Omega T2 minus theta naught plus theta z by 2 is equal to omega T naught plus theta z by 2 minus x into sine omega T naught plus theta z by 2. So this is equation number 14. Right? I am repeating once again. Omega T2 minus theta naught plus theta z by 2 equal to omega T naught plus theta z by 2 minus x. How do we know that x is nothing but bunching parameter? X into sine omega T naught plus theta z by 2. So here one important point is omega T naught plus theta z by 2 is the buncher cavity departure angle. Repeating once again, omega T naught plus theta z by 2 is the buncher cavity departure angle, and omega T2 minus theta naught plus theta z by 2. So this is the catcher cavity arrival angle. and this is Buncher cavity departure angle, and omega T2 minus theta naught plus theta g by 2 is the catcher cavity arrival angle. Now I want to differentiate equation number 13 with respect to T naught. Differentiate equation number 13 with respect to T naught. With respect to T naught, that is d2 by dt naught equal to, so 1 plus T naught, directly I want to write the answer, 1 plus T naught minus beta I v1 by 2 v naught in place of cos sin cos omega T naught theta z by 2 into omega. Is it okay? With respect to T naught, that means actually here we are having constant that equal to 0 and omega T naught. So it's sin omega T naught plus theta z by 2 equal to cos omega T naught plus theta z by 2. So omega T naught nothing but differentiation is omega, and that equal to 1 minus beta I v1 by 2 v naught into omega T naught cos of omega T naught plus theta z by 2. In place of omega T naught you can write theta naught, that is 1 minus beta I v1 by 2 v naught into theta naught cos omega T naught plus theta z by 2. So finally, in place of beta I v1 by 2 v naught you can write into T naught you can write x. So 1 minus x cos omega T naught plus theta z by 2. So this is dt2 by dt naught 1 minus x cos omega T naught plus theta g by 2, and from this dt2 equal to dt naught 1 minus x cos of omega T naught plus theta z by 2. So this is equation number 15. Now from equations 12 and 15, what is equation number 12? Equation number 12 is, I think I2 equal to, look at the equation number 12. Equation number 12 is
I2 dt2.
I naught equals to I2 dt2, right? Here I want to write, see here, I2 dt naught equal to I naught dt naught equal to I2 dt2. So dt2 by dt naught equal to capital I naught by I2, right? Capital I naught by I2. Now I want to substitute dt2 by dt naught equal to 1 minus x cos omega t naught plus theta z by 2. So by substituting that, you will get I2 of T naught equal to I naught by 1 minus x cos omega T naught plus theta z by 2. That is here with respect to T naught actual differentiation. That's why I want to write with in terms of T naught. So I2 T naught equal to I naught by 1 minus x cos omega T naught plus theta z by 2. Similarly, so suppose this is equation number 16. Similarly, I want to write in terms of T2. See, why only in terms of T naught in terms of T2? Actually, T2 is the time at the catcher cavity, T naught is the time at the buncher cavity. Because I don't want to consider within the buncher cavity and catcher cavity, at the buncher cavity, at the catcher cavity. So my assumption is T naught is the time at the buncher cavity and T2 is the time at the catcher cavity. That's why I'm concentrating only on the T naught and T2. So in terms of T2, the current you can write I2 of T2 equal to, similar to this, I naught by 1 minus x cos of omega T2 minus T naught minus theta z by 2. This is equation number 17. Is it okay? How can you get this omega T2 minus theta naught minus theta z by 2? Because already we know that what is T2? T2 equal to T naught plus tau plus T naught. Once you get the previous equation, you will get the clarity. T2 equal to T naught plus tau plus T naught. From this omega T2 equal to omega T naught plus omega tau plus omega T naught. And from this omega T naught plus theta G plus theta naught. Is it okay? And from this you can write omega T naught plus theta Z by 2 plus theta naught. What is our requirement actually? So look at the equation number 16, omega T naught plus theta Z by 2. So omega T naught plus theta Z by 2 equal to, you can write omega T2 minus theta Z by 2 minus theta naught. That's what I am writing here. I have written here, right? Look at the equation number 17, omega T2 minus theta naught minus theta Z by 2. This is equation number 17. Just 3 to 4 minutes, I will complete this topic. So after the equation number 17, now the beam current at the catcher cavity. Now current is reached the catcher cavity. The beam current at the catcher cavity is a periodic waveform. It is a periodic waveform with the period equal to capital T. With the period equal to T actually, but here already I have written that transit time equal to capital T. That's why in order to avoid the confusion, I want to write in terms of frequency. In terms of frequency, so that period is equal to 2 pi by omega. And in the diagram also I mentioned that pi by omega, right? 2 pi by omega. I'm repeating once again. The beam current at the catcher cavity is a periodic waveform of period 2 pi by omega about DC current. Therefore, so whenever it is a periodic waveform, you can express that periodic current in Fourier series. So what is the periodic current here? What is the current here? Current is I2. Current is I2 at the catcher cavity, and this current waveform is a periodic waveform with the period is equal to 2 pi by omega. So whenever it is a periodic signal, you can expand, you can express or you can expand that periodic waveform with respect to Fourier series. That means you can write I2 equal to A naught plus sigma n equal to 1 to infinity. I think you know this formula. An cos n omega t. But here, what is the time here? T2. So n omega T2 plus Bn sin n omega T2. Why you have to go for the Fourier series? Because the current waveform at the catcher cavity is a periodic waveform with the period 2 pi by omega. So no need to substitute into the formulas like A naught equal to something, An equal to something, Bn equal to something. No need to do all those things. Directly you have to write the answers, because here my concentration is not on the Fourier series representation. So I am writing directly your answers. If you have any doubts, you can substitute into the formulas. You will get the answers. So A naught equal to, answer is, I want to give the answers directly, minus pi to plus pi I naught d of omega T naught. This is equal to I naught, and the An formula is 1 by pi minus pi to pi I naught cos. In the examination also we can write directly, no problem. Omega T naught plus n theta z plus n theta naught plus n x sin omega T naught plus theta z by 2 into d omega T naught. And similarly Bn equal to 1 by pi integral minus pi to plus pi I naught sin omega T naught plus n theta z plus n theta naught plus nx sin omega T naught plus theta z by 2 d omega T naught. So these are the Fourier series coefficient for the current at the catcher cavity. So A naught, An, and Bn. So finally, by substituting all these things, the current, you have to buy at this equation. So directly, remember one thing in the examination, directly without writing all these equations, you can write directly by applying Fourier series, the current I2 equal to. You can write directly, direct equation, no problem, nothing wrong in that, you will get the full marks. The current I2 equal to DC current, that is I naught plus sigma n equal to 1 to infinity. That means I want to substitute here a n and b n. 2 I naught j n of nx. Yeah, j n nothing but Bessel's function. J n of nx cos n omega t2 minus tau minus t naught. Okay. I naught plus sigma n equal 1 to infinity 2 I naught j n of nx cos n omega t2 minus tau minus t naught. Once again I am repeating, just remember this equation, this is enough. This is enough. This is the, but remember one thing, this is the current at the catcher cavity. So current at the catcher cavity. Now just I want to go for the fundamental component. I want to go for the fundamental component of the beam current. Just write a point here. The fundamental component of the beam current at the catcher cavity has a magnitude IF equal to. Repeating once again, the fundamental component, nothing. What is the meaning of fundamental component? The lowest frequency, right? So the fundamental component of the beam current at the catcher cavity has a magnitude IF equal to 2 I naught J1 of x, or n is equal to 1. Your fundamental component is n is equal to 1. First component, first frequency component, fundamental component n equal to 1. So IF equal to 2 I naught J. So here I want to take only magnitude here. The fundamental component of the beam current at the catcher cavity has a magnitude. I want to take only magnitude, that is 2 I naught J1 of x, and this is having the highest amplitude. This is having highest amplitude whenever x is equal to 1.841. So this is the point. So from the Bessel's function, the fundamental component has the magnitude 2 I naught J1 of x, and this is having the maximum value. Maximum value whenever x is equal to 1.841. Right? Now this 1.841 you have to substitute in L optimum. That is the concept. Is it okay? So finally here, whenever the question is bunching process, depends upon the question, you have to write the answer, and remember this value from the Bessel's function, right? In today's class, so I completed bunching process, that is a bunching distance delta L, and optimum distance L optimum, and the current at the catcher cavity, that is IT.
Current equation.
Right? Okay. With this I want to end the session.